can also talk about which functions are even and odd. Sine and tangent are odd functions, therefore so are cosecant and cotangent since they go right with them. What that means is a negative angle, the negative can just be pulled out to the front. And cosine is an even function, so a negative angle doesn't really do anything. A negative input doesn't change it. You can just treat it as if it were positive and it doesn't even matter. So that's for cosine and or secant. So let's use the even and odd properties to determine the value of a couple of sines and cosines. So sine of negative pi over 6, that's related to our reference number with left-hand trick of our ring finger. So if we fold down our ring finger, sine would be the bottom part of that, so that's going to be 1 over 2. But since sine is odd, that negative just comes to the front. Cosine is even, so that negative doesn't matter. We can just ignore it, so pi over 4 is related to our middle finger. Fold that down, and we got 2 on each side of our middle finger. So cosine is square root of 2 over 2. Now, in addition to the unit circle and all of those important values related to sine and cosine, there's also lots of identities. We're first just going to look at one, the Pythagorean identity. This is the most common and most popular. Sine squared plus cosine squared equals 1. Many other properties are based off of it, like, for example, these next two are actually based off of Pythagorean, the first one, the first Pythagorean identity. So if we divided everything here by cosine, cosine squared over cosine squared would be 1. Sine over cosine is tangent, so sine squared over cosine squared would be tangent squared. And then 1 over cosine is secant. So it's just dividing everything by cosine squared and writing what that means. Same thing, we could also divide everything by sine squared, so we would get 1. Cosine over sine is cotangent, so that's cotangent squared. And then 1 over sine is cosecant, so cosecant squared. So just by dividing, we got 2 new identities. So now using the Pythagorean identity and everything else that we know, if we just know one trig function, we can find all the others, as long as we know what quadrant it is in as well. So if cosine is 3/5, we can find sine because we know sine squared plus cosine squared is going to equal 1. So if we plug in 3/5 to cosine, that would be 9/25. Subtract that from 25/25. We're going to get sine squared is 16 over 25, which square root is going to be 4 over 5. Since it's in quadrant 4, all students take calculus. Only cosine is positive, so sine will be negative there. We can then use cosine and sine together to find tangent. Tangent is sine over cosine, so negative 4/5 over 3/5. Flip the 3/5 to the top. The 5s are going to cancel. And that's -4/3. And that should be negative because, again, using all students take calculus, only cosine's positive in quadrant 4, so that means tangent's negative. And then the inverse of cosine is going to be secant. So if cosine is 3/5, that means secant would just be the flip, 5/3. Cosecant is the flip, the inverse of sine. So instead of -4/5, we flip it, 5/4, and it's negative. And then cotangent is the inverse of tangent, so flip -4/3 to become -3/4. So we're able to find all the others just by being given one ratio.